Okay, this is lesson 4C, Standard Deviation. So the first thing we're going to do is we are going to write down a few things about standard deviation. So, first of all, you see the definition states that it is a measure of how spread out the data is from the mean. So it's compared to the mean. How spread out is it from the average? What you're going to write down next is what I am enclosing in this yellow box. So we're talking about the difference between a high standard deviation and a low standard deviation. Okay, I'll give you a minute to write that down. We took a look at these equations before, and now we're including a new equation. The new equation is standard deviation equation. Now, we will use this equation only when we are given n and p. So, what that means is this. Sometimes we're given n, sometimes we're given p, and sometimes we're given both. So what they're going to do is they're going to tell you how much data you're going to arrange. So you're either going to be arranging or organizing maybe 50 pieces of data. And maybe the average of that data, maybe the percent, the probability might be 83. Well, if the probability is 83%, it needs to be in decimal form. So you need to divide that by 100 always. So it will be 0.83, okay? The n number is always the total number of raw data, no matter what, okay? So this is just a range of the variation of the equation. So this is what you would do, and you would put it all in that order. Now be careful. Your root sign on certain calculators is automatically going to open a bracket. So my suggestion to you is this. Since the p number right here is the original p, so in this case, if I were using the example I did, my p-value is 0.83. This value right here is 1 subtract that. So I can easily find out what both of these values are, the p and the 1 minus p. They're both going to add up to 1.0. So you're basically taking this number and you're going to multiply it to the number that makes it create a 1, which would be 0.17. Okay? 1 minus 0.83 is 0.17. So there's two ways you could do this. You could type it in your calculator. Let's just choose a different, we'll choose our n numbers 500 like I said. We have 500 pieces of data. So if we've got our equation, we would have our n number 500 times by our p number that is going to be in the decimal form. So we would times it by 0.83. I'm not using brackets because under a radical sign, brackets can be very scary because this one already opens a bracket. If you put too many brackets in there, it's not going to know what to do. So now we're going to put in the next number, and the next number is my 0.17. It's my 1 minus my p. So instead of literally typing in 1 minus p, just type in what it actually gives you for 1 minus p. Okay? That'll be an easier way to plug in all the numbers in this situation. Okay? And it's going to reduce the probability of you getting an error when you type it in. So, we can do it on the graphing calculator. On the graphing calculator, it does it for us, of course, when we use our one variable list, one variable stat. Now, when that happens, it's going to give us a little loopy symbol like that. And that's the symbol, but in the calculator, it's going to have an X beside it. And it's right above the n that tells us the total number of data. So we're going to try an example on the next page, but this is going to show us how we deal with two sets of data if we've got two lists. So, on the next one, determining standard deviation. So, this one is showing you how to clear your lists, and it's also showing you about one variable stats. It's a review on how to do one variable stat. So everybody's going to grab their calculator. We're going to turn it on, and we're going to go to this next example. We're going to talk about this high school basketball team. So we got the heights of a high school basketball team. And we're going to do this a couple different ways. This way we're going to be doing it using the calculator. So I've got 5 numbers. I need to put them in my list. So I'm going to grab my calculator and I'm going to go to my lists. Your lists are found by going stat, enter. Okay, stat, enter. If you need to clear your list, you highlight it, so you move your up arrow, and then you hit clear, enter, not delete. Okay, you type over what's already there. Back to the lists. So the first thing we're going to do, stat, enter. Now we type in list 1. 170, enter. 182, enter. 193, enter. 193, enter. And 212. Do I have a mode in my list? 193, good, it's the one that's been repeated. Okay, once we have all the numbers in our lists, we're going to hit the stat button again. We're going to go across the top, and we're going to hit enter. And we hit enter again. Okay? So this is that little 0 with the loop I was talking about right above the N. That's our standard deviation number. Okay? We usually want it to 2 decimal places. In this case, we round it to 2 decimal places. It's going to round up anyway to give us 0.9. So we want to record 2 numbers, the mean and standard deviation. So the mean is our top number, the X with the line, and the standard deviation is the one above the N, the 0 and the X. Okay? So we have our mean is, our mean is 190, and again, that's centimeters we're recording in. And then it's got a standard deviation. The standard deviation is going to be 13.9. Now what that means is the average spread between each of these numbers is 13.9 numbers. That's what they're saying, is the average spread between the numbers is 13.9. Now if we take a look, I've got 12 there, 11 there, nothing there. Why do we have a big standard deviation? Because we have one kid that's super tall. This guy right here would be considered an outlier in our list. He's quite a bit bigger than the rest of them. Okay, so that being said, that means that this guy is going to be a little bit of an outlier. Okay? Okay, good to go with that? All right. So that's why our standard deviation looks like it's a big, big number when our numbers are actually kind of close together. Okay? And it's because the outlier skewed our results a little bit. Now, what do you think would happen if I took that number out? Would my results become much closer? Absolutely they would. And that's what's going to happen with an outlier in every time you deal with an outlier. If you remove that outlier, it's going to make your results more consistent to where it should be. Now, what if, on letter B it says, what if every player grew by 5 centimeters? Is that going to change the average height? Yeah. Their average height would be 5 centimeters bigger, right? So the average height, so the mean height, yes, it would change. It would be 5 centimeters more. Okay, if everybody grew 5 centimeters, well, it's going to grow 5 centimeters. Okay? What about standard deviation? Standard deviation, no, it's not going to change at all. Because remember, that's how spread out the numbers are. We're not changing how spread out they are. We were just adding something to each number. Okay? So this will not change at all. Okay? The only thing that would change would be their average height. Okay? Now, what if we're given 2 lists of values? Sometimes they give us 2 lists to analyze. And that's okay. If we're given 2 lists, we just have to put it into 2 lists. And we tell our calculator then that we have to analyze 2 lists. Now, if we use our calculator one more time right now, and everybody just looks at it real quick. Everybody hits stats, calc. You're going to notice number 1 is 1 variable stats, and number 2 is 2 variable stats. We're still only using number 1, even if we have 2 lists. A lot of kids will go down to number 2. Oh, we got 2 lists and stuff. No, that is not what we're doing. We're not doing 2 variable stats. That means we're analyzing 2 different variables. We're not. We're only analyzing 1. So we're using 2 lists with 1 variable stat. And there is a specific way to do that. So on the next page, this is going to tell you how you have to put it in your calculator when we've got 2 lists. We have to literally tell the calculator there's 2 lists. And this is the way we tell it, okay? Using absolutely every single one of those, okay? Well, right now, example 2 gives us 2 lists. So one of them is our data list. The other one's called the frequency list. The frequency list is the one that we're going to say L2. So, back to your calculator, you're now going to plug these numbers in. Now don't forget, if it's a horizontal table like this one, the first row is always list 1, the second one is always list 2. Okay? So, going to our calculator, we are going to just hit stat, enter. Now you can see I've already got numbers in there. You can type over top of those or you can clear them. So I'm going to clear them. I'm going to highlight. I'm going to use my up arrow and highlight list 1. Highlight means it's highlighted in black there. So I'm just going to hit clear, enter. Okay, don't hit delete, just hit clear. Now you can retype your numbers. So I've got 0, 1, 2, 3, and 4. Then you're going to go to list 2, use your right arrow. Right arrow goes to list 2, 5, 10, 4, 3, 1. Okay. So now we're going to start with the very next same step. We're going to hit stat calc. Okay? So, lists are loaded, stat calculate. I still want a one variable stat. So, number 1 is what I want. So I hit enter from number 1. But now I need to tell my calculator you're using 2 lists. So I have to say list 1, comma, list 2. So if you look above the digit 1, right above it to the left, you're going to see L1. And if you look above the number 2, you're going to see right above it L2. Now some of you might have had a different screen that came up. If you have a different screen that comes up, it's going to say list and frequency list. So it's going to say this to you. List and frequency list. Okay? For list, you're always going to have list 1. List 1 should always show up there. Where we did list 2, you guys are going to put list 2 there. Okay? So that's where you're going to hit second 2. And then hit enter calculate. Those of us that don't have that screen, we still have this sitting in front of us. We have to hit L1, comma, L2. So I'm going to start again so you can see what it is without my screen being so cluttered. Okay, so I'm going to hit my stat calc 1. Okay, so stat calc 1. If you have the other list, list 1 should show up first. If it doesn't, you type it in. By typing it in, I mean you'd hit second 1. Second 1 means L1's going to come up. Then you hit comma if you've got my screen that I'm typing on. If you don't, if you've got the other screen that I'm pointing to on the left here, then that's where you hit enter. It'll go down to frequency list. In frequency list, you're going to now type what we're typing, second 2. Okay? And then you hit enter. Once you hit enter, it's going to solve it for us. Okay? So that gives us our answer using 2 different lists. Okay? So I'm going to go back to my question I was on. It skipped over a question for us there. Okay. So, from my number of hits and my number of games. So, must be talking hockey here if we're talking about the number of hits per game. So, right now I want my mean. My mean is my top number. We're going to 2 decimal places. 1.35. What is my standard deviation? 2 decimal places. 1.09. Okay, 1.09 is what you should have. Okay. How's everybody doing? What's that? Pardon? This? That's mean. Yeah, that's mean. It's got new stat symbol. Okay. Let's just clear this off. Okay, did everybody have all that information in there? Everybody's good to go? Yeah. Okay, perfect. Now we're going to take a look at another example. This example now, this is where you're going to write a little definition. What happens right here when given a histogram? Well, how do we create our lists? This is how we have to create our lists with a histogram. So I'll get you to write that down, please. Push pause now and play when you're ready. Okay, now we're going to create our lists. We do so by this. Here is our X values. We are going to use the values that only create the bars. So we're going to notice 1 through 5 for the quadratic quiz. So we're going to write the numbers 1, 2, 3, 4, and 5. And then what we do is we write how tall they went on the left-hand side. So if I go across for number 1, how tall did the first bar go? You went at a height of 1. How high did the second bar go? 3. How high did the tall bar go? 6. These are Mo's remember. How high did the 4 go? You went 4. Good. And the fifth bar, how high did he go? 1. Good. We're going to do the same thing now for the stats quiz. When we take a look at this one, now our numbers are going to be going 3 to 7. So we're going to be using the numbers 3, 4, 5, 6, 7 for my X values. And they all went the same height. They're all the same height of 3. So now what we need to do is we need to analyze both of those, but we got to do them separately. So we're going to start with our quadratics quiz, and we're going to go to our calculator, and we are now going to type in the numbers. So everyone's going to hit stat, enter. Okay, so we're going to retype above our numbers, and the numbers, we're going to clear our lists, and retype. So numbers 1 to 5. And then list 2, 1, 3, 6, 4, 1. So there's our first set of data in both lists. Okay? So this again is where we're going to do a one variable stat, but we're going to go L1, comma L2. So stat, right arrow to calculate. Enter. Second 1, comma, second 2. Enter. We want the standard deviation and the mean. So we always want the top number, 3.07, and the bottom number, that's going to round to 1.0. Okay? So, on the bottom of your page are where we're going to put the results. Okay, you're going to see a spot on the very bottom left for mean and standard deviation on the left-hand side of your page. So, I'm just going to move this over so I can write them down. This is where I'm talking right here. So our mean, 3.07, and standard deviation was 1.00. The 0.99 was going to round up to 1.0. Okay? Now we're going to do the exact same thing for that stats quiz on the other page. So, we go back to our lists, and now the numbers change. So now the numbers I'm putting in are 3, 4, 5, 6, 7. Was there a 2 in there too? Or just 3, 4, 5, 6, 7? Oh, I forgot the 4. I did forget 4. Okay, 4, 5, 6, 7, and they're all the same height, 3. So once you've got your lists loaded, again, we're going to hit Stats, right arrow to calculate, enter, L1, comma L2, because we use both lists. Second 1, comma, second 2, enter. So now we've got a mean of 5, and a standard deviation of 1.41. So 5 and 1.41. So now what we're going to do is we're going to take a look and we're going to answer the questions up here. And we're going to answer it two ways. One with the values and one where it says without doing any real calculations. So just by looking and interpreting the graph. So without doing any real calculations, which one has the greater mean? Well, if we take a look at the actual picture, if I look over here, all we're looking for is about the middle of my graph. This guy's middle, his average will be between 3 and 4. Okay? This guy's, what's the middle between 3 and 7? The number between 3 and 7 that's the middle is 5. Okay? So we could estimate our averages, meaning the means, right from just the picture itself. Now, from the picture itself, can we tell which data is clumped closer together? Yeah, we can. The way we can tell is by our X numbers. What is the difference in our X numbers? Here, I'm only going 1 to 5, and our bottom bars, our 2 bars here on the bottom, they're very, very small. So most of my data is clumped between the numbers 2, 3, and 4. That's where most of my data is. So it's clumped closer. Whereas if you look at the next one, everything is spread equally. So there's no real clumping of the data. It is all spread equally. Okay? And we can tell that from the digits now. So, who had the greater average? Well, stats did. How come? Why did the stats have the bigger average from the picture? Because the middle of 3 and 7 is 5. Compared to 1 and 5. Okay? So they compared the difference between 3 and 7 versus 1 and 5. Well, the difference between 1 and 5, the middle there would be 3. So that's how the greater mean is the guy who's got the bigger number. Who's bigger, 3 or 5? 5 is bigger. Okay? But the greater standard deviation? Well, stats also had the bigger standard deviation. How come? Because he's more spread out. Okay, all the data was way more spread out. We noticed with the quadratics quiz, it was more closely clumped to the center. Okay? That's the difference between both of those. Now we're going to take another example, but this one's going to compare 2 different light bulbs. So, let's say you're going shopping for light bulbs, and you want to find out which kind of light bulb is the better brand. Now, what are you going to be looking for if you're looking for a light bulb? How long it lasts and energy efficiency. So, we're looking here only in times of the mean light, the mean standard light for this. So, we've got the mean and the standard deviation. So this one here is showing us that they wanted to check the lifetimes of hundreds of hours of batteries. So they took 8 light bulbs of each brand and they analyzed them. And this is what the mean for each was. So now what we're going to do is we're going to find the mean for that grouping and then the mean and standard deviation for this grouping. And then we're going to compare them according to the numbers. Okay, so we go back to our lists. Now, is this going to be a list where I go list 1 and list 2? Is oval going to be in list 2? No, because I'm comparing them. The only reason they put them in a table like this is just for the convenience of the data. But really, it's not really a table. They should be kind of split. You're not going to be putting them into list 1, list 2. This guy goes into list 1. We will do the analysis on slim. After we do that, we erase list 1, and then we put in oval into list 1 and do the same thing. Okay? So, we're going to clear out list 1. Again, of course. So, stat calc. We're going over, and we're going to clear it. All right, let's put our numbers in. once you've got your numbers in, again, all we're doing is stat, count, one variable stat, enter. Okay, that's giving us all the information we need. So, pardon me? Did I really? Well, let's see. Yes, I sure did. 7.6. That'll change my data. That'll change my data a lot. There we go. Okay, so you're going to get 8.04 and 0.61. So 8.04 and 0.61. Okay, those are the values we got for slit. Now we're going to do the same thing for oval. Okay, push pause down, play when you're ready. Okay, we've got our values now. Now we're going to analyze the values. The first question's talking about average. If we're talking about average in the very first question, average, is that referring to your mean or standard deviation? Always the mean. Because average is another word of saying mean. Okay, so they want to compare these numbers. So it says on average, which one lasts longer? Oval lasts longer. Good. Then it says, which bulb is more reliable? So when we talk about reliability or consistency, reliability or consistency is standard deviation. The smaller the number, the more reliable and consistent it is. So who's smaller? Slim is. So since slim is more reliable, which light bulb, even though the other one lasts longer, doesn't last quite a bit longer? Does it make a huge difference in how long it's going to last? No, not a huge difference. So therefore, you should always go with your reliability. You should always go with the terms in this question specifically. Okay? So, which one's more reliable? Smaller standard deviation always. Okay? And that will always ring true. And you're always going to get questions where they're going to give you a simple format, where they're going to give you a list of numbers, and then they give you a second list of numbers. And they're only going to ask you two questions. Who's got the better average? Who's more consistent? Average is always mean. Consistency or reliability is always standard deviation. And those will be always the two things they want to compare. The next one, hockey stick manufacturer. Last example here. Estimates from a past quality control inspection that 5.2% of those sticks contain flaws. If an inspector randomly selects 800 sticks, what is the probability that at least 50 of them are flawed? Well, the first thing we got to do is we got to figure out what the hay bales we're going to do with the hockey stick info. So we've got to, did they ever give us a list of data? No, they didn't give us a list of data. If they don't give us a list of data, we are not able to use our one variable stat. We actually have to use, no, we can't use the L1, L2. That's what I'm talking about. We can't use one variable stat. We have to find out who N and who P are. N is the total number of raw data. So how many hockey sticks do they talk about? 800 of them. Now, what percent of them are flawed? 5.2% of them are flawed. We need to divide that by 100 to get the decimal that goes for probability. So that's going to be 0.052. Okay? Now what we're going to do is we need to find the mean and standard deviation using those first two equations. So mean is equal to N times P. So I'm going to take my N number, 800, and I'm going to times it by my P number, 0.052. So what is the average number of sticks that would be affected here? What is your mean number of sticks? The calculation is going to give us 41.6. That means that the mean number 6, yes, as a decimal, is 41.6. But if I were to ask you what is the average number of 6, you would just say 41 if we were talking whole 6, because we can't have 0.6 of a 6. But if they want the mean number, we still want it as a value. So yes, the mean is 41.6. So we put it over here, 41.6. So that means in that batch, 41.6 of them are flawed. They're defective. Now we're going to take a look at standard deviation. The equation is n times p. Well, we had the n times p. So 800 times 0.052. Well, now we got to times it by that 1 minus p. Well, if I go 1 minus p, I'm timesing it by 0. What's it going to be? One subtract 0.052 is going to be the other number we put in here, 1 minus p, 0.948. Now, the reason we did the math first is so that when we put it all into the root sign, all we've got to do is multiply the digits. We're not going to run into calculation problems where we've got to multiply other digits, where we've got other brackets causing us issues. So what we're going to type in now is 8 under the root sign, 800 times 0.052 times, whoopsie, 0.052 times 0.948. We just write all the numbers in a row, multiply them, 6.28. That's what we get for a standard deviation. Okay, so again, 6.28, that's our standard deviation. That's telling us how far apart the numbers are spread, remember, okay? That's not telling us an exact number of them. That just tells you how far the data is spread from the data we gathered. Okay, this concludes standard deviation, lesson C.